In solving equations part 3, we're going to learn how to solve equations that have variables on both sides. Our guiding question says, when solving an equation, you will get one of three possible solutions. What are these three possible solutions, and what do they mean? By the time we finish this lesson, you should be able to answer this question. When solving equations with variables on both sides, you follow the same steps for solving equations that we've already talked about. But when you get to step 4, you're going to add or subtract the variable terms first to get the variables on the same side. Then you're going to add or subtract the constants to get them on the same side. Lastly, you'll multiply or divide if necessary to get the variable by itself. And we'll look at a couple examples of this. For our first example, we're going to look at solving a basic equation with variables on both sides. Like we talked about just a minute ago, we said that we follow basically the same steps. We first look to clear the equations of fractions and or decimals. Doesn't apply here. The second step would be to clear the equation of parentheses. Again, does not apply here. Third step, combine like terms on each side of the equal sign. Doesn't apply here. I already have that done on this one. So then I go on to step 4. I'm either going to add or subtract to get my variable terms on the same side. What I always look to do is I look to find which variable term is the smallest. So on the left side I have 5x. On the right side I have 2x. 2x is the smallest, so I'm going to move it over. Since it's positive, I do its inverse operation, which would be minus. So I minus 2x on both sides. 5x minus 2x is 3x. Then I bring down my plus 2. My 2x minus 2x zeroes out on that side, and I have 14. Now I'm going to get my constants on the same side. So I look at the constant that's on the same side with the variable term, plus 2, and I do its inverse, minus 2. And I get 3x. 2 minus 2 zeroes out. 14 minus 2 is 12. And then lastly, I have 3 times x, so to get the x by itself, I do its inverse operation. So the inverse of multiplying by 3 is dividing by 3. So I divide both sides by 3, and I get x equals 4. And then I can quickly do my check and see that it works. 5 times 4 is 20. 20 plus 2 is 22. And on the right side, 2 times 4 is 8, and 8 plus 14 is 22. So I know that it is correct. Now, using an equation with variables on both sides, I'm going to look at this problem. It says it takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. So how many pages would the designer have to make in order to save time using the new software? Whenever you want to see what a better deal is, or when you're making a comparison between things, you set the two things you're comparing equal to each other. So I have the first thing which says 1.5 hours to make one page of a website. And then I have using the new software, it would be each page in 1.25 hours, but it takes 8 hours to learn the software. So if I set this equation up, then the variable I'm going to be talking about here is the number of web pages. So first I'm going to say let x equal the number of web pages that the designer would have to make in order to save time using the new software. So I'm going to look at using the old software. It takes 1.5 hours per page. So I would write that as 1.5 times x. 1.5 times each page that it's to make. Then the other side says it would take 1.25 hours per page, so 1.25 times x, but it also takes 8 hours to learn it, so I'd have my plus 8. So now I'm going to solve this. I'm going to get my variable terms on each side. 1.25 is smaller than 1.5, so I'm going to subtract the 1.25x from each side, and then I get .25. So I get 0.25x equals 8. So then I have 0.25 times x. So to get x by itself, I do its inverse operation. So instead of multiplying by 0.25, I would divide by 0.25. So I have 8 divided by 0.25, and I get x equals 32. So at 32 pages, it means that the old software and the new software would be exactly the same. So to answer the question, how many web pages would the designer have to make in order to save time using the new software, I would have to say more than 32 pages. Because at 32 pages, they were the same. So at more than 32 pages, the new software would cost less. Now in this example, we're looking at solving an equation with grouping symbols. So following our steps, again, no fractions to clear, but there are parentheses to clear. So I'm going to do my distributive property. 2 times 5x is 10x, and 2 times negative 1 is minus 2. And then on the other side, 3 times x is 3x, and 3 times 11 is 33. So now I'm going to look to get my variable terms on the same side. 3x is smaller than 10x, so I do the inverse of positive 3x, which would be minus 3x. And if I do it on one side, I also have to do it on the other. So 10x minus 3x is 7x. Bring down my minus 2. That zeroes out on the right, and then I bring down my 33. Then I get my constants on the same side. So the inverse of minus 2 is plus 2. So I get 7x equals 35. The inverse of multiplying by 7 is dividing by 7. So divide both sides by 7. And I get x equals 5. So my solution here would be x equals 5. And then I could quickly check it, either in my head using mental math or by using my calculator. Now in the previous examples, for each equation there was only one solution, such as in problem 3, x equals 5. In some equations though, this will not happen. We can have a problem that we call an identity. And what an identity is it means that all real numbers are the solution because any number works as a solution for that equation. We also will say that that means all real numbers. And that's what that symbol there stands for. And then there are also problems which are going to have no solution. And in that case, no number makes that equation true. And the following problems will show examples of these. So if we look at this problem 4a, following my steps, on the right side, I need to clear the parentheses. The left side stays the same, 10x plus 12. And the right side, I do the distributive property. 2 times 5x is 10x, and 2 times 6 is 12. Now, then I would look to get my variable terms on the same side, and if I look here, I have a 10x on both sides. So if I subtract 10x from both sides, what happens is the variable terms zero out, and I'm left with 12 equals 12. So I ask myself, does 12 equal 12? Yes, it does. If I'm left with a true statement with no variable, this is what we call the identity. And what it means is our solution is all real numbers, which means any value that I picked to put in for x would make this true. And you could check this out by substituting a variety of different numbers in for the x's, and you would see that this would be true. In example 4b, following my steps, there are no fractions, there are no parentheses, but on the right side I do have like terms to combine. So the left side again would stay the same, 9m minus 4, and on the right side I can combine negative 3m plus 12m, which would give me 9m, and then I'd bring the plus 5. Now if I look again, now see it's same thing as above. I have the same variable term, 9m. So if I were to subtract the 9m from both sides, just as above, the variable terms zero out, and I'm left with negative 4 equals 5. So I ask myself, does negative 4 equals 5? Obviously not. So since that is false, then my answer is no solution. And what that means is there is no value of the variable m that I could put in to this equation that would make it true, thus having no solution. So to answer our original guiding question, what are the possibilities that can happen when I solve an equation? My possibilities are that I can get one solution, and an example of that would be x equals 4. That means the equation is true when x equals 4. There is only one solution. The second possibility would be the identity, which means that my solution is all real numbers, which means that any value that I would like, I could put in for my variable and it would make the equation true. And then the third possibility is no solution, which is exactly what it means. There is no value of the variable that I could put in that would make that equation true.